we'll start with, okay. We have a question. First, we'll do some question and then we'll start graphical representation of question, okay. So first, because we have already read that acceleration, right? Rate of change of velocity. So we'll be doing some of the questions today and then we'll study the graphical representation of question. How we are going to draw the motion in the graph. So first question is saying, a train starting from rest. Starting from rest means what? Starting from rest means what?
It's not started moving.
Yeah, started from rest means it has started from an initial velocity as 0. If there is the question saying starting from rest, first see this. If a question is saying starting from rest, if a body has started from rest, starting from rest, then in the question if it's present, then we take u as 0. Okay, because the body has started from rest, it means that its initial velocity is taken to be 0. Okay, and then attains a velocity, whatever the velocity it will attain, it will be come under v. Okay, the final velocity. Fine. So when in the question it's given that a body has come to rest. A body has come to rest after traveling a few distance. Okay, after traveling for a few distance with some velocity. Okay, so yes, hello Adhika. Okay. If in the question is given that body has come to rest after attaining some of the after traveling through some of the distances, then it will be we'll take v as 0. Come to rest means the final velocity will be taken as 0. Okay, means initial velocity would be something, and then it has come to rest. It means it has got final velocity as 0. Fine. Okay, it means starting from rest, it has got u as 0. Come to rest, it will get v as 0. Okay, and one thing more, when it has said that the motion of the body is uniform, if it's saying that motion of the body is uniform, it means that a will be 0. Motion of the body is uniform means it is covering equal distances in equal interval of time, right? Equal distance in equal interval of time. It means the velocity is the same throughout the what? Motion. So the motion will be if the motion is uniform, then a acceleration will be 0. It means there is no acceleration. There is no difference between v and u, means v minus u will be equal to 0. Whatever be the final velocity is the initial velocity. So it will v minus u, when v will be equal to u throughout the motion, then what will happen? V minus u equal to 0. It means a will be 0. V minus u upon t. A is v upon u. A is v minus u upon upon t. Right? So if v will be equal to u, then v minus u will be equal to 0, and hence a will be equal to 0. So if you are given in the question that motion of the body is uniform, then you will write a equal to 0. Okay, it can come in a 1 mark question that what will be the acceleration in a uniform motion. So it will be 0. Okay, because there is no any kind of change in velocity. Means v equal to u, and if v equal to u, then what will happen? A will be equal to 0. Okay, so in the question it's asking the train starting from rest. It means we'll take u equal to 0. Fine. Initial velocity as 0. Attains a velocity of 72 km per hour, means this is our v. Right? Attains a certain velocity. In 5 minutes, this is your time. Assuming that the acceleration is uniform. Here the acceleration is considered as uniform. Fine. You don't get confused between the motion is uniform or the acceleration is uniform. If the motion is uniform, then acceleration is 0. And if the acceleration is uniform, then if acceleration has come into the play, then the uniformity gets lost. Means uniform. There is no any kind of uniform motion. Okay. If the acceleration is there in the motion, then there is no uniform motion. Okay, and the uniform motion is there, then there is no acceleration. Fine. Is that clear? Or not? If it's uniform motion, getting my point, getting the thing that I am telling or not? If it's uniform motion, then there is no acceleration. Okay, and if there is acceleration, whether it's uniform or non-uniform, no matter what it is, if it's uniform or non-uniform, acceleration means the velocity is changing, and when the velocity changes, the uniformity of the motion gets lost.
Yes.
Okay, so there is non-uniform motion. Fine.
Yes,
Is that
ma'am.
clear? Arpita, are you getting? If
Yes,
the
ma'am,
motion is
I
uniform,
understood.
if the motion is uniform, then there is no acceleration. If the acceleration has got come to its has got there, means
Ma'am, it's
has
like
come
if
in the motion.
ma'am, change direction, like ma'am, if a car is going at uniform speed, and then suddenly changes
Come
direction.
again, Arpita.
Ma'am, like if a car is going at uniform speed and we change direction, that time there will be acceleration, no?
If a car is changing its direction,
Yes, ma'am.
yeah. If the direction is getting changed or the magnitude is getting changed of the velocity, then I've already told that either of this thing changes, then the velocity, then the uniform motion is not there. There is non-uniform motion. If the direction has got changed of the velocity, then also the motion will be called accelerated motion. Okay, suppose in circular motion,
Yes, ma'am, I
circular
understood.
motion, what happens if the direction changes at every point of the circle. Okay, so here whether or not this is the the same velocity throughout the circular motion, but the here velocity is changing. How? Because direction is changing, and when the direction is changing, the uniform motion is not there. When the uniform motion is not there, then we say this motion as accelerated motion. Okay, fine. So circular motion is an accelerated motion. Fine. So motion of the body. Question. Assuming that the acceleration is uniform, find the acceleration. So we will find the acceleration, the distance traveled by the train for attaining this velocity. I think this second part we cannot do right now because we haven't studied equation of motion. So the first part we'll be doing. Okay. Then we will study the second the equation of motion. Then we'll do its second part. So what is the what's given in the question? Let us write what given in the question. So first given that u equal to 0, v equal to 72 kilometer per hour. We can change it in second. Okay. So how 72 kilometers? So 72 into 5 by 18, cancelling it by 4. So we'll get 20 meter per second. Okay. Time is given as 5 minutes. We can write 5 into 60 so that it will become 300 seconds. Okay. Razi, getting? Okay. Always look into this unit that is given. If it's not the same, then make it same first. Then you start doing question. Okay. Don't put directly in the formula. First see the unit, whether the unit of all the component are same or not. Okay. Means it must be, if it's in meter per second, then everything it should be in meter or second. Okay. So this is writing the formula v minus u upon t. This v minus u means v is our 20 minus 0 upon t means 300. So 20 by 300, 0 got cancelled. We have got 1 by 15 meter per second square. Okay, this is our acceleration, and acceleration is written in meter per second square. Its SI unit is meter per second square. Shazan, switch on your camera. Advika, switch on your camera. And where is she has left again? Sharia, switch on your camera. Everyone switch on your. No one has switched on. Listening to what I'm saying.
Yes, ma'am.
Yes, ma'am. 2 minutes.
Ma'am, I can't switch on my camera.
Yes,
Why
ma'am,
you
I'm not at home right now.
So what? You are attending the class now?
Yes, ma'am, but ma'am, is it okay like that?
Okay,
Ma'am,
fine.
I can turn it on like 2 minutes, ma'am. I'll be home.
Okay. So this is our answer. A is equal to 1 by 15 meter per second square. Okay. So what I was saying, I forgot. Let us come to the question B. Car accelerates uniformly from this to this. Okay.
Ma'am,
This
question is
to
not
this.
visible.
Now is it?
Yes, ma'am.
Yes, ma'am.
The car accelerates uniformly from 18 km per hour to
Ma'am,
36
initial
km per hour.
velocity is 18 kilometer
Yes.
and final velocity is 36 kilometer an hour.
36 km per hour. And time is given, so acceleration can be calculated easily.
Ma'am,
Okay, fine.
36 minus 18 divided by 5.
No. This 36. This is what I was telling. Just consider this. This is in kilometer per hour. This is in second. How can you do this?
Oh, yes.
First, you have to convert it in meter per second. Both of them. Okay, and then you will be doing the question. Do it fast, Razi. Do it fast, everyone.
Ma'am, which one? Which question? You're saying?
Yes.
Ma'am, which question were you saying?
B.
Which one?
B.
Okay.
It is 5 meter per second.
Is it visible now? Clearly?
And the answer is 1 meter seconds minus 1. Acceleration.
1 meter per second square.
Yes, yes, ma'am. And to find the distance, we will use 1 by UD plus half UD square. In this,
Right now, we are not going to do this. First, we will, because we have to do according to all the students.
no, I'm asking that to find that we use
Yeah,
as equals
yeah,
to
we have to use twice. Even from the second equation of motion also. Begin.
Have I got the answer?
You got the answer? What you got the answer?
1 meter per second.
1 meter per second square. Okay. Arham, have you got?
I got the same 1 meter per second square.
Yes, ma'am. Even I got that.
Okay. Firdaus, Shalia,
Yeah, ma'am.
you got the answer?
No, ma'am.
Fine. So everyone has got the answer, right? So just converting this 36 km per hour into meter per second, 18 km into meter per second, and then we can easily find by the formula V minus U upon T. Okay. Third question: the brakes applied to a car produce an acceleration of 6 meter per second square in the opposite direction to the motion. This question is again of second and third equation of motion. Okay. So now we will see graphical representation of motion. Okay, so graphical representation of motion is very interesting. It's very interesting. Okay. First, we will see distance time graph. Okay, first we will see distance time graph. First case, distance time graph. Okay, time is always taken in the x-axis. Fine. So first motion, Shazan, where are you looking? First motion is this. What kind of motion is it? I told you.
I know.
Ma'am,
Ma'am, the object is in rest and the time is going on.
Object is in rest, ma'am.
Arjika, can you tell me what kind of motion is this?
Ma'am, the velocity is 0.
Ma'am, this is a graph, ma'am, and in ma'am, it's a graph question, and ma'am, in this we're supposed to find the speed, right?
T-drive? T-drive means? What
Ma'am,
are you
I
trying to
understand.
say?
Can you repeat? Ma'am, can you repeat? I can't hear you.
What kind of motion, what this graph is representing? Just
Oh, ma'am, I thought you were saying that what type of graph, like what is this? Ma'am, what this graph is representing, 1 second. Ma'am, I think it's representing uniform motion.
It's representing uniform motion. I already have told in my earlier second or third class that what kind of graph is this, what this graph is representing. Look
Ma'am, is it
carefully.
velocity? Ma'am, is it velocity?
Look at carefully that what is there. D is there, distance, time is
Yes,
there.
ma'am.
Okay.
Ma'am, time is
Here
and
we are
speed.
saying that this at every point, here the distance is same.
Yes, ma'am, so it's uniform
No.
speed.
No,
Then?
distance is same. Means there is no any kind of motion. Distance is neither decreasing nor increasing according to the time, as per the increasing time.
Ma'am, I explained the same answer, just in
Yeah.
different way.
Yeah. Means means we can say that the body is in rest. There is no any kind of motion here. Velocity has no role to play.
Ma'am, how? Ma'am, how? I don't understand. How is it at rest?
If you have gone somewhere, okay? If you have gone somewhere, you have gone to some shop. You are there. You went there. Okay, at 12 p.m. At 12 p.m. and you are remaining there in the same seat till 6 p.m.
Yes,
If you invest here,
yes.
here your time is increasing. Here your time is increasing. Time axis is increasing, but the distance is remaining the same. So what will be our graph? The same distance. Suppose someone is noting down what you are doing right now at 12 p.m. 12 p.m. She's in the someone is noting down that she's in the shop and in the same chair, sitting in the same chair. Okay, what she is doing at 1 p.m. She is again in the same chair. She's again in the same chair in the same shop. What she is doing is 5 p.m. She is again in the same chair in the same shop, and then again in 6 p.m. also she is again in the same shape, in the same shot.
Yes,
Okay?
ma'am, I understand.
So here our graph
So,
is
ma'am,
like this.
the arrow that you've drawn on distance, ma'am, it's going up. Doesn't that like mean that the distance is increasing?
Oh my god, I have just drawn the arrow to make you understand. I just to make you understand. This our graph will look like this. The same.
Oh, ma'am, so the distance was increasing, the graph would point upwards first, right? Like the graph would go upwards and then continue.
So I have started noting down just right from 12 p.m. Right from
Yes,
12 p.m. Okay, right from 12 p.m. I've started noting down.
Ma'am, I got it.
Okay, I'm not considering this. I'm not considering this because I'm not considering this time. This time. Okay,
Yes,
if I would have considered this, then it's okay. You have gone you have gone somewhere, and I've started noting down from there on. Fine. So because if I will draw the graph like this, then you may not understand that what I have drawn, right? If I will draw the graph like this, then right in the time axis, the time is increasing, and the distance is same as 0.
Yes, ma'am.
Nobody will understand the same things, or it will be overwriting. Right. So this is why the graph is drawn like this, to show the motion in rest. I mean to show the body in rest. Fine. Okay.
Yes, ma'am. Ma'am, sorry, not on mute. Yes, ma'am, I got it.
Have you got it, Shalia? Razi, you got it? That the body is in rest. If you are given distance time graph, and you have given you and you are given the it's a graph like parallel to what axis? X axis. Fine. Parallel to X axis, then the body will be in rest. Okay. Now you will get, if you get the graph like this? This is your time axis. This is your distance, and you have got the graph like this. What do you think it's telling? What do you think it's telling, or do you think it's telling correct or not?
Ma'am, I think distance is increasing, time is not increasing.
Distance is increasing. Yes, distance is increasing in this graph.
And ma'am, time is increasing.
And
at a point, object is there, it is at rest. After moving some distance.
Anna, what do you think? Is it in rest? Is it doing uniform motion?
Ma'am, I think it's going in uniform motion. No.
And I think
it's just like it's at rest for most of the time, and then suddenly it just goes very fast.
something is going very fast, even with more than the speed of light. That the time is not getting changed, but the distance is getting changed. So how can this graph be possible? This graph is wrong. Okay, someone is not Superman. Neither Superman can do this kind of motion. Fine. Neither Superman can do this kind of motion. Neither even light can do this kind of motion, because light also takes some time to travel. Fine, right? Here seeing light, the body is taking more time in doing the motion from this 0 to somewhat this distance d, whatever the distance is. So nobody can do this kind of motion. Means they are traveling, and time is not increasing. How can it be possible, right? So this is this. If you will be asked this kind of graph, then you just say this graph is impossible. This is not the motion here. The time is the same, but the distance is increasing, which is impossible. Fine. Okay. Now distance time graph, another distance time. This we will say that not possible. Second, third. Third is distance time graph is like this. Okay. It's like this. This is uniform motion. Okay. This is uniform motion. The distance is getting changed according to the time. There is equal distances are covered in equal interval of time. So this will be regarded as uniform motion. Fine. Now the last graph for DT, this. Okay.
Ma'am, it's going exponentially.
Yes.
It's going exponentially. It's like it starts off slow, it's going on faster, faster, faster.
I didn't get you. What you're saying?
Ma'am, what's happening is it's accelerating. So it's like
It's accelerating. Yes, it's accelerated motion, non-uniform motion, non-uniform motion, or you can say it's accelerated motion. Okay, because here unequal distance is getting covered in equal interval of time. Okay, so this will be non-uniform motion, not non-uniform acceleration. This will be non-uniform motion and accelerated motion. Or you say accelerated. When the uniform gets non-uniform, Means when the uniformity gets lost of any motion, then acceleration has come. Fine. Now we'll see distance time graph is done. Now we'll see what velocity time graph. Velocity time graph. First motion will be like this. So what kind of motion is this? Advika, tell me what kind of motion is this? Advika, you there? Shizan, Razi,
Yes, ma'am.
what kind of motion is this?
Ma'am, it is. Wait, ma'am, maybe it's the same one which you showed me before.
Means rest.
Yeah.
Means rest.
No, I don't think it's rest.
Ma'am, uniform velocity.
It's uniform motion.
Ma'am, that would have been uniform velocity.
Razi, what do you say?
I think the object is in rest.
Rest. In distance time graph, it was in distance time graph, the same graph was there, and you said it's uniform motion, and now it's velocity time graph, and you're saying that it is in rest.
No, ma'am.
Sharia, what do you think the motion is? Sharia, you there? She's not there. Advika, yes, Aram, what?
Ma'am, I think it's a
Yes,
uniform.
ma'am.
And I'm saying motion.
Advika, what do you think this motion?
Ma'am, in this one, ma'am, the time keeps on increasing, but the velocity does not increase. So, ma'am, I think that the body is at rest in this case also.
Velocity is not increasing, but there is some velocity. No? There is some velocity. This is like 10 meter per second. Every time the body is in 10 meter per second.
Ma'am, but but there's very less velocity.
Uniform velocity.
You consider is 100 kilometer per hour. I have not given anything. I just assume that velocity is there. Now, if the ant is traveling somewhere, then you say that it is in rest because she.
Ma'am, but then in the previous question that we did, ma'am, it was a similar one, ma'am, but there you said that the distance wasn't increasing.
I say it was distance. It was about distance. Here it's about velocity. If the body is not at rest, even if it is doing 0.1 meter per second, 0.1 centimeter per second. Okay.
Yes, ma'am.
Where is some velocity? V is there. Some velocity. This is not at zero.
Ma'am, velocity is 0. That initial velocity is 0. I think that's it.
Yes.
I think
Ma'am, initial velocity will be 0. So, ma'am, it is a uniform velocity time graph.
yeah, it's uniform velocity.
Yes, ma'am, it will be a uniform velocity, ma'am, because even if the velocity
Initial
is 0.
velocity is zero. How? Initial velocity is zero. How? Here must be initial velocity.
No, ma'am, velocity is 0. The whole velocity is 0.
Yes, ma'am, even I think so.
But my velocity can be 0. Velocity is a vector quantity, so it can be 0.
But it is
So
not.
we can consider it as a uniform velocity time graph.
How can you consider this from this point that it is zero? Can this point it is zero or this point is zero? Tell me.
The one that you marked
Is this point zero or this point zero? You will consider you will deny the graph.
the second point. It's uniform acceleration, uniform motion.
There is some velocity and it's
The
going at the
velocity
same
is
velocity all the time. So this motion is what? Uniform motion.
Uniform motion.
Okay, got it or not, Razi? You got it? How this motion is uniform?
Yes, ma'am.
No, if you haven't got it, then tell me. Let me.
Ma'am, the acceleration is not increasing, but the object is still moving, and the time is increasing. So it is in uniform motion.
Yeah, if there is no acceleration, then the body is in uniform motion. Okay. Here there is no role of acceleration because your velocity is not increasing. Okay, velocity is same. Fine. This is so simple. So simple to understand.
Yeah, man.
Here,
Very easy to understand.
this. What is this? What kind of motion?
Acceleration.
And uniform
Uniform what?
velocity.
Uniform velocity again. Okay.
From uniform acceleration.
Okay. Razi.
Ma'am, non-uniform motion.
Uniform motion. Okay. And then non-uniform motion is acceleration.
Ma'am,
Right.
I said non-uniform motion because it is because the velocity is increasing, and then and then object is also accelerating. So it must be non-uniform motion.
It must be non-uniform motion. Or you say means non-uniform motion and it's uniform acceleration, accelerated motion also, right? This is non-uniform motion, right? For this is non-uniform motion means acceleration has come into play, right? Because there is non-uniform motion. Non-uniform motion means acceleration. And what kind of acceleration? Because acceleration has also two parts. Is it uniform or non-uniform? This is uniform acceleration because velocity is increasing equally with the equal interval of time, right?
Ma'am, with
So
respect
like
to time.
in this distance time graph, the distance was increasing equally in equal interval of time, right? So it was uniform motion, means uniform velocity, right? But it was in motion. Fine, uniform velocity. Here its velocity is increasing equally in equal interval of time, so there will be uniform acceleration. What was in the question? Here we saw the question now. A train is starting from rest attains a velocity 72 km per hour in 5 minutes. Okay, assuming that the acceleration is uniform. Acceleration is uniform. The same graph is this. The same graph is this. It has what? Started from rest, means started from zero and attains some velocity like 72 km per hour, and in 5 minutes, like so let us suppose that this time is 5 minutes. This time is showing 5 minutes, and then this isn't it the same graph that the question was, right? The graph is representing the question now. This is 72 km per hour and this is 5 minutes. So and it's starting from the rest zero. So it has attained 72 km per hour in this time 5 minutes, and then this and the acceleration is what? Uniform. This acceleration is uniform. Okay, fine. Okay, if the motion is not non-uniform, then there are two possibilities, because now we'll talk about acceleration. Now in acceleration there will be two possibilities, whether the acceleration is uniform or non-uniform. Okay, if the graph is a straight line, then the acceleration is uniform, and when the graph is not a straight line, is like this, then the acceleration is non-uniform. Means here VT graph. If the graph is like this, then the acceleration is also non-uniform acceleration. Fine, Shazan? You got it? You getting?
Yes, ma'am, I'm getting it.
Okay. So acceleration is non-uniform. Here in this graph, acceleration is non-uniform. Obviously, the motion is non-uniform because acceleration is there. Now we'll talk about acceleration. Is it uniform or non-uniform? The acceleration is also non-uniform. Fine? Because velocity is not changing equally with equal interval of time. Okay. Now we'll see what is the acceleration time graph. AT graph. For AT graph, this. What is it? What this is representing? Tell me fast.
Maybe uniform acceleration. Ma'am, wait.
Maybe uniform acceleration. And Aram, what do you say? Rosie, what do you say? Jika has left the class.
Uniform acceleration? But then acceleration was same. So maybe I think it was
Rosie,
acceleration. So uniform motion, ma'am.
uniform motion.
Sorry, ma'am, uniform acceleration, sorry, not motion.
Rosie, tell me.
I don't know, ma'am. I cannot think of anything.
You cannot think of anything. What you are seeing here, just see now. Don't think, just see what it's showing. What the motion is showing.
Ma'am, it is showing that the
Velocity is constant.
Here I can't see velocity anywhere. I can't see velocity anywhere.
Means acceleration, sorry.
And Rosie, what you can see in this graph. Just tell me what you can see. Don't think it.
Yes, ma'am. I can see that the object is accelerating.
Okay.
And
And?
at a time, what?
Is acceleration changing
No,
with
no,
the
ma'am.
time? It's not changing with the time. It means if something is not changing in the time, it means it's uniform, right?
Yes, ma'am.
Right or not? If something is not changing with the time, it means it's uniform. It means acceleration is uniform. So we'll see that we'll say that this is uniform acceleration. Simple. What we say? What we said here? What we saw here? The velocity was not changing. It was same. So we called it uniform velocity or uniform motion. Right? The velocity was not changing. Then yes, Aram, if the velocity was not changing, then it was uniform velocity.
Ma'am, actually, is there any this time displacement graphs?
Yes,
Ma'am, is there any time displacement graph?
displacement time graph. It's same, Aram. We can just that they distinguish them in like they are vector, they are just scalar. And if you are plotting the graph, then it's same,
Okay.
right?
If you know the
No, it's same displacement time graph or distance time graph. Okay. Even you say speed time graph or velocity time graph, it's same. Acceleration time graph. When the acceleration time graph is like this, what kind of motion is this? Obviously, this is non-uniform motion. But what kind of acceleration is it?
uniform acceleration.
Yes.
No, is it
What do you say?
non-uniform acceleration?
Non-uniform acceleration. What do you say, Razi?
Now I think it
What do you
is
say,
uniform
Razi?
motion.
Motion uniform. And if you are talking about acceleration, how can the motion be uniform? If you have talked about acceleration, how can the motion be uniform? A means what? Uniform motion. The uniformity of motion is not there. A means non-uniform motion. Now we will talk about what kind of acceleration is this. Is it uniform or non-uniform? Don't ever say if you are saying if you are seeing the acceleration, don't ever talk about motion. Okay, because it's non-uniform motion. Obviously, accelerated motion is non-uniform. Okay, only non-uniform motion is accelerated. Uniform motion is never accelerated. Fine. So if A is there, what kind of acceleration is there? What it's representing? Here the A is changing. It means it is non-uniform acceleration. Simple. There is nothing to think. There's only to see and tell that what kind of motion is this. Whether AT graph is like this or whether AT graph is like this, the acceleration will be non-uniform. Okay? The acceleration will be non-uniform because acceleration is changing in this also, acceleration is changing in this also. Okay? Because here the acceleration is changing, no? Non-uniform acceleration. Fine? It's 53. So these kind of graphs we have. Okay? If we are given like this, suppose this is velocity time graph, and the body has a motion like this, O, A, B, C. Okay? This is some kind of 10. Let's consider this 10 meter per second. And then this is 0. Okay? This is time T2, time 5 seconds, 15 seconds, and then here 20 seconds. Okay, fine. T is in second. Okay, what this motion is representing from O to A. What this representing from O to A? O to A, it's
Non-uniform motion.
non-uniform motion. Yes. Velocity is changing, right? Velocity is changing, so the uniformity will get lost. Uniform motion. Okay. No uniform motion means non-uniform motion. So we can draw acceleration from this. We can tell what will be the acceleration from O to A. The motion will be non-uniform velocity, or we can say non-uniform motion. So
Ma'am, I just want to ask
acceleration
a question. How it is non-uniform in this section?
from O to A, just from O to A, not the
Oh,
whole.
I thought from B to A. Okay.
No. O to A. I just talked about O to A. Okay. O to A. Non-uniform velocity or motion. Then we can find A with this, calculate A with this. Here our V is 10, here our U is 0, and time is given as 5. Okay, so it will be 10 by 5, which will be equal to 2 meter per second square. Okay, and now from A to B, what is it? From A to B,
Uniform motion.
uniform motion. Uniform motion, because the velocity is not changing. Okay. Okay, this is V. Okay, consider it. This is V. From B to C,
Ma'am, non-uniform.
non-uniform, and velocity is what? Decreasing or increasing?
Ma'am, increasing.
Yeah, decreasing. It's going down. It's going down, now. This is decreasing. So there will be deceleration. Non-uniform, it will be non-uniform velocity, and it will be deceleration. How? Because it's
For negative
Ma'am,
acceleration.
the velocity is going to the negative side.
what? What and how? What you say?
Ma'am, what is the term for negative acceleration?
Deceleration or retardation.
Retard.
But you have to show it with the A only, but there will be negative sign. Okay, and if you are writing that retardation, then you will write the positive acceleration. Then you will write your answer in positive. And if you are saying that acceleration is equal to this much, then you will say that then you will write the answer in negative. Okay, let's see what I'm doing. Like here, you see that V is your 0 minus U is your 15 because here it was 15, right? 15 minus, what was the time lag? What is time? 5. Okay, so 5. Minus 15 by 3. How much it will be? Minus 3 meter per second square. Here you are saying it's a is equal to minus 3 meter per second square. If you are saying that acceleration, then you will say that a is equal to minus 3 meter per second square. And if you are saying that retardation is there, then for retardation you will say that it will be 3 meter per second square, because retardation itself is negative in meaning. Okay? If you are writing retardation, don't write negative sign. If you are writing acceleration and you have got negative acceleration, then you write that yes, minus 3 meter per second square. Okay, fine. So always you need to write this. Most of the time you will need to write this a as minus 3 square. Okay, fine. Okay, fine. So let us close our